right, so today we're going to talk about parabolas, and you should have already seen the Conic sections animation video that's on this playlist, and if you haven't, then make sure you go back and do so. But parabolas are created by a plane intersecting the cone at an angle that's not 90 degrees. So that would create a hyperbola. If it intersects at an angle and intersects the base of the cone, then it creates a parabola. So that's what we'll talk about today. All right, so a parabola, the definition of one is the set of all points that are equidistant from a fixed line, which is the directrix, and a point that's not on the line, which is the focus. All right, so here's a whole bunch of definitions for you. And in this diagram, you can see that here's our directrix of vertex. You should be very familiar with a vertex already, just from Algebra 1 and Algebra 2, talking about a parabola. The directrix is not actually part of the parabola, so it's more of a reference line. And it's the same distance away from the vertex as the focus is away from the vertex. So that distance is p, or 1p. From the focus, parallel to the directrix, you have what's called the focal width, and that's a distance of 4p. So it goes 2p to the left and right, or it could be, if it opens sideways, 2p up or down. It is also possible for parabolas to open at an angle so that it's not opening directly up, down, left, or right. But the ones that we'll talk about in this chapter will be these. All right, a focal chord is any chord that goes through the focus. So I could create a focal chord like this, but if it's not parallel to the directrix, then that's not the focal width. So there's an infinite number of focal chords. There's only one that would be the focal width, this length. Another thing you should be familiar with from Algebra 2 is the axis of symmetry. We'll refer to that occasionally, but mostly we'll talk about the focus, vertex, and the directrix. All right, so other things to remember is that the vertex is halfway. It's the midpoint between the focus and the directrix. The axis of symmetry is going to be perpendicular to the directrix. All right, if you need to pause the video, do so. Otherwise, we're going to move on to the equations that you need to know. And then we're going to use the equations to do some examples. All right, so here are your basic equations. Now, the ones that you should already be familiar with are these. This is standard form. This is vertex form. You probably used this in Algebra 2 or even Algebra 1. All right, and in these parabolas, they only opened up or down. Now we're going to focus on ones that open up, down, left, or right. So if the x is being squared, then that's a parabola that will open up or down. We're just going to be solving for x squared now, right, as opposed to solving for y in our equations. And then this value is our 4p, which is our focal width, and we're going to use that to mainly, that'll be how we graph our parabolas. If it's solved for y squared, so if the y term is squared but the x term is not, then these will be parabolas that open either right or left. So the easy way to look at it is this variable tells you which direction it opens. So if it's positive, then it goes to the positive y. So if you think of your positive y-axis, it'll open up. This is negative, it goes to the negative y-axis, so that would go down. Positive x-axis is to the right, and negative x-axis is to the left. All right, now these are for when the vertex is at 0, 0. Certainly that's not always going to be the case, so sometimes they'll be shifted over. Right? You have an h and a k value, and same thing here. Here's h, here's k. So your vertex will be at h comma k, and your focal width is always a positive value. So no matter what number is in front of your non-squared variable, make sure that's positive when you write down your focal width. All right, so find your books. We're going to go through these 4 examples, and they're on page 835. All right, so problem number 7 gives you y squared plus 28x equals 0. All right, now it says to graph. However, in order to graph, you need to get it into this format. So I'm going to get y squared all by itself, and we have negative 28x. So here's the form that I'm going to look at. This variable tells me which direction it's going to open to, and since it's negative coefficient, it's going to go to the negative x direction, which tells me that it's going to open to the left. Since there's no number being added or subtracted to x or y, my vertex is at 0, 0. And it would be helpful to find the value of p. So I know that 4p is equal to negative 28, so p is equal to negative 7. Okay, so you can start graphing, and that will help you actually answer some of the other questions. So this one wants you to identify the focus, the directrix, and the focal width. All right, so I'm going to start at 0, 0. I'll label that as my vertex. It opens to the left. So since it opens to the left, my focus has to be on the left side, and it should be p units away. So here's my focus. That's at -7, 0. My directrix should be the same distance away. All right, now the directrix is a line, so that's a vertical line at x equals 7. All right, these are equidistant. This distance is p. And then from my focus, I'm going to go up 2p. So up 14, right, and down 14. And here's my graph. All right, so to review, this is 2p, that's 14 units. This is another 2p. So grand total, that's our 4p. And so my focal width is equal to 28. All right, so we needed our vertex, focus, focal width, and our directrix, and we needed our graph. And now we're all done with the problem. All right, next problem is problem number 19. All right, so this one we need to do a little bit more work. It's 2x squared minus 12y, 12x, minus y plus 18 equals 0. All right, so I know that it's a parabola because only one of my variables is squared. So I need to figure out which variable is being squared. That's my x's. So I know that I'm going to try to get it into this format. Since it has more than just x squareds, I know I'm going to have a vertex that's not at the origin. There's this x term here. All right, so I'm going to keep the 2x squared and the negative 12x over here on the left side. I'm going to move the y and the 18 to the right side. All right, now for this problem, it's going to be easier to complete the square if we divide out by this coefficient. So since there's a 2 in front, I'm going to divide everything in the whole equation by 2. So I have x squared minus 6x equals 1/2 y minus 9. All right, so now I'm going to complete the square. So to do that, you're going to take half this term, so negative 6 divided by 2, and I'm going to square it. Negative 6 divided by 2 is negative 3. Squared would be 9. Right, a little formula for that would be half the middle term squared. So b divided by 2 squared. That goes in your box. All right, now if I add 9 to this side, I have to also add 9 to this side to balance out my equation. And then this should be a perfect square trinomial, something that can be factored. X minus 3 times itself. So we'll call that x minus 3 squared. This is 1/2 y, and the negative 9 and 9 cancel out. So now I have it in the correct format. Because it's x squared, I know that it's going to open to the y direction. Since y, the coefficient of y is positive, this means it's going to open upwards. All right, so now I need to find where the vertex is to start my graph. So the vertex is at 3, 0. So there's x minus 3. That means it moves 3 to the right. And so 3, 0, there's no number here. Okay, so now I should be able to graph and then identify the other remaining pieces of information. All right, so I'm going to start at 3, 0. Here's my vertex. It's got to open up. Now my 4p is equal to 1/2, which means that p in this case is 1/8. So this is going to be a pretty tiny graph here. So we're going to go up 1/8 to make my focus, and down 1/8 to make my directrix. All right, so my directrix is y equals negative 1/8. My focus is up 1/8 of a unit from the vertex. So instead of 3, 0, it's at 3, 1/8. All right, and then I need to go, my focal width, I need to go 2p to the left and 2p to the right, which would mean I go 1/4 to the right and 1/4 to the left. So grand total, my focal width is 1/2. Which is my coefficient of y from earlier. All right, so I should have everything labeled there. All right, we're going to do 2 more examples. I might do an extra one after we're done with this. All right, so these 2 are word problems. So find your book and read number 24. It says, one of the largest radio telescopes in the world is the Effelsberg Radio Telescope, located 25 miles southwest of Bonn, Germany. Determine the diameter d of its parabolic reflector given the specifications in the accompanying figure. Assume that x and y are in meters. All right, so they give us the equation. It says that the focal ratio is equal to 0.3. And it shows in the diagram that the diameter, so the parabola, opens to the right of this parabolic telescope. Now, a formula that you need to know is that the focal ratio of these disks or telescopes is P over D. All right, so how can we find P? From this equation, we know that 120 is equal to 4P. So P is therefore equal to 30. All right, so now I know that if the formula for focal ratio is P over D and the focal ratio is 0.3, I know that P is 30, I can find D. So multiply both sides by D, I get 30 equals 0.3D, and then divide by 0.3. So I get D to be equal to 100. And it said that the units in this problem are in meters, so this must be 100 meters. So that's how large this telescope is, which is pretty large. Right? All right, number 25. All right, so this problem, you get this diagram here. You have a parabolic arch, and it says that the blue portion of the curve, or the blue curve is a portion of the parabola. Introduce a horizontal x-axis, going this way, passing through the vertex of the parabola, which would be right here, so I need to put in my x-axis right here, with the vertex corresponding to x equals 0. All right, find an equation for the parabola in the form x squared equals negative 4py. Since it opens downward, it should be negative 4py. All right, then we're going to do part B. We'll come back to that. All right, so we know that it has to fit this format. And they wanted the vertex to be at the origin. It has a horizontal x-axis that passes through the vertex. All right, so here's my vertex. That's at 0, 0. All right, now according to this diagram, this is 15, and all the way across is 40. So if this distance is 15 and all the way across is 40, this must go to negative 20, and this must go to positive 20. So a point on this parabola would be 20, comma, negative 15. Right? And this point, because this goes down 15, would be negative 20, comma, negative 15. I'm just going to focus a little bit here. Okay. All right, so now we need to come up with an equation in this format. So I know 0, 0 is my vertex, so I don't need to change anything. But I need to put in either this point or this point in for x and y. So I'm just going to go with this point. So x is 20, so I'm going to do 20 squared equals negative 4p times negative 15. So if I do 20 squared, that's 400. That gives me 60p. And if I divide both sides by 60, I get p to equal 40 over 6, which is 20 thirds. All right, so my actual equation is going to be x squared equals, now I need to multiply this by negative 4, so it's going to be negative 80 thirds y. All right, so that was part A. Part B, after you found the equation, says use the equation determined in part A to compute the height of the arch that's 5 feet away from the center. That is at x equals 5 and x equals negative 5. So since it's symmetric, we just need to find one of them. All right, we basically need to find where this point is, but we want to know this distance. So that's our final answer. All right, so if I want to know 5 comma what, like what point here is on the parabola, I'm going to put 5 in my equation. So I do 5 squared equals negative 80 thirds y. So I get 25 equals negative 80 over 3. So 75 over negative 80 equals y. And that gives me negative 15 sixteenths. All right, but it's asking you how tall is the arch, so we need this distance. We just found that this distance is 15 sixteenths downward. So I want to find out the difference between 15, right, this is the total height, and take away that little part. So if I do that, I get 14 and 1/16 feet. If you do that as a decimal, it's 14.0625 feet tall. So I guess either answer would be fine. All right, let's just try one more extra example. So let's work backwards. Let's say that you're given a parabola with a vertex at 5, 3. And if I know that my focus is at 5, 4, then you should be able to come up with the equation. Okay, so I think it might help to draw out a diagram for this one. And it'll help us, one of the most important things to figure out is what direction does it open. So if we were to find 5, 3 would be my vertex. I'll put a V for vertex. My focus is at 5, 4. So what does this tell me? Well, since my focus always has to be within my parabola, it must go like this, right? So it must open upward. I'll just draw a dotted line for now. Okay, so I know that it opens up. If it opens up, I know that it has to be the format 4py minus k and x minus h squared. Okay, so how far is p and where's my vertex? Well, the vertex was given to you, so we know it's y minus 3 and x minus 5 squared. And for p, well, p is the distance between the focus and the vertex, so that would be 1. So this should be 4 times y minus 3 equals x minus 5 squared. All right, if we needed to double check, all right, my vertex is at 5, 3. P is equal to 1. 2p is telling me to go 2 to the left, 2 to the right, so my total focal width is 4. You could even check using your graphing calculator. Especially for this problem, right, we could solve for y. So if I were to divide by 4, I would get 1/4 times x minus 5 squared. And then I'd have to add 3 to both sides. Okay, and if I graphed it, So there's a parabola opening upwards. I could double check that my vertex is at 5,3. Right? And can't exactly check on the calculator that your focus is at 5,4, but at least we know the equation matches with the information that was given. All right, so make sure that you took notes and wrote down the examples and definitions from today's video, and then we will talk about these types of problems tomorrow in class.